Here we have a problem on evaluating limit, that is limit extends to negative infinity 4x square negative sine of 5x over x square negative 7. Okay, it seems to be a little complicated to evaluate this limit because the limit we have for the variable x is negative infinity, and one more troubling stuff is the sine 5x over here. So everything is in terms of x or x square, something like that. We can easily evaluate this limit. So that is how to factor the variable with the largest exponent in numerator and denominator, and we can simplify. But the thing is, we have sine 5x over here. How do you have to evaluate this sine 5x for x equals to negative infinity? So for that, we can consider a squeeze theorem to evaluate this limit. Okay, for that, first let's understand what is squeeze theorem. So to understand squeeze theorem, what I need to do is I have to consider three functions in a component inequality. So let's say g of x less than or equal to f of x less than or equal to h of x. Okay, now we have three functions in a component inequality. Now what I'm going to do is I'm going to take the same limit for x for all the three functions in this component inequality. Say that limit extends to a g of x less than or equal to, I'm taking the same limit for x for the function f of x also, that is limit extends to a f of x less than or equal to limit extends to a h of x. Okay, I've taken the same limit for the variable x for all the three functions g of x, f of x, and h of x. Okay, now let's say the value of this limit is capital L. Then we get less than or equal to limit x tends to a f of x less than or equal to, and also say the value of this limit also the same capital L. Okay, now so the value of limit x tends to a f of x is between the two same values capital L. Okay, according to squeeze theorem, whenever we have a limit of a function between two same values, then the value of the limit of the function also is the same value, that is limit x tends to a f of x equals to L. So this is called squeeze theorem. So whatever stuff I have discussed over here on squeeze theorem, the same I'm going to apply in our problem, that is to evaluate the given limit over here. Okay, now let me erase the stuff over here. Okay, now what I'm going to do is, so I'm going to consider only this particular stuff, for that is sine 5x over here, so that I can set up a component inequality. So let me write sine 5x. Okay, so here this 5x represents an angle measure. So whatever angle measure we have over here, what is the maximum value of sine? Always the maximum value of sine is 1. So it doesn't matter what angle measure over here. So the maximum value for the trigonometric ratio sine is 1, and the minimum value of the trigonometric sine is negative 1. Okay, now I got a component inequality, because if I want to use squeeze theorem to evaluate this limit, first I have to set up the component inequality, and then for each quantity I have to take this limit, and we have to evaluate as we have seen in squeeze theorem. Okay, now so here when I look at the given function over here, the sine 5x is having negative sign, but here sine 5x is positive. So to make this sine 5x as negative, I have to multiply all these three quantities by negative 1. So when I multiply this negative 1 by negative 1, it will become positive 1. When I multiply this one by negative 1, it will become negative sine 5x. And when I multiply this 1 by negative 1, it will become negative 1. So in an inequality, whenever I multiply the quantities by negative value, by the same negative value, I have to flip the inequality sign. So here already we have less than or equal to. Since I multiplied all the three quantities in this component inequality by negative 1, so just have to flip this less than or equal to inequality sign as greater than or equal to. And the same thing we have to do for this one also, greater than or equal to. Okay, now, so we have 1 greater than or equal to negative sine 5x greater than or equal to negative 1. Okay, now I'm going to change the order of the quantities over here. Actually, here we have the first quantity is 1, the second quantity is negative sine 5x, the third quantity is negative 1. So if I change this order, then I'll have this first quantity and the third quantity negative 1 as the first quantity, and we have negative sine 5x, and we have the first quantity as third quantity over here. So whenever I change the order of the quantities in an inequality, again I have to flip the inequality sign over here. So already we have greater than or equal to, it will become less than or equal to, it will become less than or equal to. Now I need to get the function exactly over here in the middle. Okay, so already we have negative sine 5x, but we need 4x square. So for that I have to add 4x square to all the three quantities in this component inequality. So when I add 4x square to this negative 1, then I will have 4x square negative 1 over here. And when I add 4x square to this middle quantity, I'm getting 4x square negative sine 5x less than or equal to. When I add 4x square to this one, it will become 4x square positive 1. Okay, now almost I got it, but still we have the denominator x square negative 7 over here in the middle. So for that I have to divide all the three quantities by x square negative 7. Okay, let me do it. I divide the first one by x square negative 7, and this one by x square negative 7, and this one by x square negative 7. Okay, now in this component inequality, so whatever function I have in the given limit, I have exactly in the middle over here. So now in my next step, what I need to do is I have to take the given limit, that is limit extends to infinity. So for each quantity in the component inequality over here, I mean for each function, here I have taken the given limit, that is limit extends to negative infinity for each function over here in this component inequality. So that I have written over here. Okay, now let's evaluate the first over here. That is the first of limit extends to negative infinity for x square negative 1 over x square negative 7. So here the limit for x we have here is negative infinity. So whenever I evaluate a function at infinity of the variable, negative infinity or positive, whatever it is, I have to factor the variable with the largest exponent in numerator and denominator. So usually we do this kind of trick in evaluating limit when x approaches, I mean when the variable in the limit approaches either negative infinity or positive infinity. So here in numerator, the variable with the largest exponent is 2. So we have to factor x square in numerator. In denominator also we have the variable with the largest exponent is 2. So that is we have to factor x square in the expression denominator. Okay, now let me do it. So that is limit extends to negative infinity. So now I factor x square from the expression in numerator. When I factor x square out, to get the stuff inside the parentheses, I have to divide the terms of the expression over here by the one I factor out. Then I'm getting 4x square over x square negative 1 over x square. And the same thing I have to do in denominator. That is I have factor x square out. Then in parenthesis, I have to divide the terms of the expression by the one I factor out, that is x square over x square negative 7 over x square. Okay, less than or equal to, I have to write the middle stuff as it is. It is limit extends to negative infinity 4x square negative sine of 5x over x square negative 7 less than or equal to, so limit extends to negative infinity. So here I have to do the same thing what I've done in the first limit, that is I have to factor the variable with the largest exponent in numerator and denominator as well. So in both numerator and denominator we have the variable x with the largest exponent 2, so I factor x square out. Then inside we have 4x square over x square positive 1 over x square. In denominator also I factor x square out. So when I do so, I'm getting x square over x square negative 7 over x square. Okay, here when x approaches negative infinity, so like x will take a negative value. When I plug in a negative value for this x over here, so because of the even exponent, it will become a positive value. So the same thing for this one. So we have the same positive values over here and here. Since both of them are equal and both of them are positive values, we can cancel them. So x square will cancel out, and the same thing x square will cancel out, and x square will cancel out. And here x square and x square will cancel, this x square. So let's cancel. Okay, now let me write the remaining stuff. That is limit extends to negative infinity. We have 4 negative 1 over x square in numerator, and in denominator we have 1 negative 7 over x square less than or equal to limit extends to negative infinity. We have 4x square negative sine of 5x over x square negative 7 less than or equal to limit extends to negative infinity. And here we have 4 positive 1 over x square over here x square cancelled. We just get 1 negative 7 over x square. Okay, now what we can do is in the next step, so in the first limit and the last limit, we can plug in the limit we have for x, that is negative infinity has to be plugged in for the x over here and here. When I do so, 4 negative 1 over, okay, when I plug in negative infinity, there is a very large negative value for this x. Because of the square, it will become a very large positive value. So usually we write the large positive value as positive infinity. 1 negative, the same thing, 7 over, when I plug in a very large negative value for this x, and when it is squared, it will become a very large positive value, that is again infinity. So less than or equal to limit x tends to negative infinity, 4x square negative sine of 5x over x square negative 7 less than or equal to, so again the same thing, that is I have to plug in negative infinity for this x. Then when it is squared, it will become a very large positive value, that is positive infinity, 4 positive 1 over infinity divided by 1 negative 7 over infinity. Okay, now 4 negative. So when I divide a finite value, that is non-zero value 1, by a very large positive value, so what will happen to the value of this fraction? So for example, let's consider the value of the fraction 1 over 10. It's equals to 0.1. When I divide 1 by 100, it will become 0.01. When I divide 1 by 1000, it will become 0.001. So when I keep on increasing the denominator, what's happening in the value of the fraction? It's getting smaller, 0.1, 0.01, 0.001. So when I take a very large positive value as a denominator over here, so what will be the value of this fraction? It will be too small, that is 0. So whenever I divide 1 or any finite value by a very large positive value, it will become 0. So 4 negative 0, 1 negative, the same thing. So when I divide a finite value 7 by a very large positive value, it will become 0. So less than or equal to limit x tends to negative infinity 4x square negative sine of 5x over x square negative 7 less than or equal to 4 positive. The same thing. When I divide 1 by a very large positive value, the value of the fraction becomes 0, then 1 negative 7 over infinity also will be 0. Okay, now let me erase the other stuff and continue the problem. This is the last step we have had in our previous working. Okay, now let's simplify this one. So 4 negative 0 is 4 and 1 negative 0 is 1. So 4 divided by 1 is just 4 less than or equal to, let me write this stuff as it is. It is limit x tends to negative infinity. So 4x square negative sine of 5x over x square negative 7 less than or equal to, so the same thing, 4 positive 0 is 4 and 1 negative 0 is 1. 4 over 1 is still 4. Okay, now so the limit of the given function is between the two equal values of 4. So according to Squeeze theorem, so whenever we have a limit of a particular function is between two same values, then the evaluation of the limit of the function equals to the same value, whatever value we have over here. So the evaluation of the given limit, that is limit x tends to negative infinity 4x square negative sine of 5x over x square negative 7 equals to 4. So we got the value of the given limit that is equal to 4 according to Squeeze theorem.